I'm mute. Going live on LinkedIn. And the elevator music is off. Welcome back to our hockey studio and the Rethink the Rink livecast. Today is Thursday, and it's the final day for the students at Carnegie Mellon before the grand finale tomorrow in the Ice Hockey Make-a-Thon. Rethink the Rink is a unique collaboration between the hockey team Pittsburgh Penguins, the Carnegie Mellon University, and Covestro. This week, every day, we will take a look at behind the scenes of this amazing collaboration and talk with direct participants. On Monday, we talked with Phil Bork, a former hockey player from the Pittsburgh Penguins. On Tuesday, we had a chat with Dan Bourgeois from Bauer Hockey, an equipment manufacturer. Yesterday, we talked with one of the expert coaches, Mark Bondi from Covestro. If you missed any of these broadcasts, just go to YouTube, type in hashtag Rethink the Rink, and you'll find them. Today, we'll dive into TechSpark, the physical space where the Ice Hockey Make-a-Thon is taking place, and chat with two wonderful participating students. How does it feel to create, ideate, innovate, and prototype and pitch your ideas just within a time frame of 5 days? But before we go there, let's take a quick recap of what Hockey Make-a-Thon is all about, and then we dive into the TechSpark makerspace.
A leading materials producer, a world-class university, and a hockey team with a history of winning championships. In 2018, the Penguins teamed up with Covestro and Carnegie Mellon University for a groundbreaking collaboration with one goal in mind: to impact the safety of the game without impacting how it's played. The result? New discoveries and even new prototypes to advance safety innovation in hockey for players at all levels. In March of 2018, the inaugural Rethink the Rink kicked off the world's first hockey Make-a-Thon, a week-long workshop hosted at Carnegie Mellon University's Makerspace. As the only sport with a hard physical boundary, the dasher boards that line a hockey rink were the perfect project. The challenge? Increase their overall safety without impacting how the puck plays off the boards. In less than 4 days, teams of students using Covestro materials and guided by their material experts designed, developed, and prototyped safe dasherboard solutions and presented their ideas. The winning design was refined with the help of dasherboard manufacturer Athletica and tested using an automotive standard just outside Detroit, Michigan.
Firing in 3, 2, 1.
These new dasher boards have since been installed at the Covestro Innovation Rink at the UPMC Lemieux Sports Complex and underwent further testing. The hope is to continually evaluate its overall performance with the goal of expanding these new dasher boards to rinks all around the world, including NHL arenas. 1 year later, the Penguins in Covestro were back on CMU's campus for year 2 of Rethink the Rink, this time focusing on goalie masks. The challenge was to develop a material solution that increased player protection without inhibiting performance, and the results astounded judges. Goalie helmet prototypes inspired by technology in car airbags, and the winning design inspired by rams and woodpeckers, some of nature's most self-protecting creatures. The results even captured the attention of experts from world-renowned hockey equipment manufacturer Bauer Hockey, and the winning prototype is now in testing with a goal of commercialization in 1 or 2 years. Expectations entering the hat-trick year of Rethink the Rink were high, and CMU students met the moment. Year 3's Make-a-Thon focused on a player's shoulder and elbow pads. The hope was to create a solution that would make them even lighter with a greater range of motion and flexibility while protecting more of the hockey player. After a week of ideating with Covestro and Penguins equipment staff, even a pandemic pause and a quick shift to a virtual presentation ceremony couldn't keep the momentum from flowing. The results and ideas were astounding, again piquing the interest of Bauer Hockey. Now the winning prototype is in the early stages of evaluation and development at the manufacturer, and yet another tangible success story resulting from this brilliant partnership. Now here we are, gathering together both safely in person and virtually throughout the week for year 4 of Rethink the Rink with this annual Make-a-Thon event. The goal is the same: make hockey a safer sport to play for players of all levels without impacting how the game is played. And as always, we look forward to seeing the results. Good luck, everybody.
So that was an amazing video. Welcome, Samantha. Welcome, Hamza. Good to see you.
Thank you. Good to see you.
Good to see you as well.
So it's amazing to see behind you the maker space, the tech spark. This is where the magic happens. This is where the innovation of hockey is taking place. The prototype is taking place, and we can see your colleagues and fellow students right there working on their projects. It's an amazing sight, and we have a good internet connection.
Yes.
We are on campus, so.
And I just saw your practice pictures, so definitely an exciting moment this on Thursday. Before we go on with our conversation, just let me remind you of our wonderful audience that you can comment and ask questions and type questions and comments right on this channel. Also to Samantha and Hamza. So take an opportunity and use it, please. So, Samantha and Hamza, and I hope I spell your name right, Hamza.
Yeah, that's perfect.
Okay, cool. So, let's start with you, Samantha. Tell me a little bit about yourself and what made you sign up for the Make-a-Thon. And what's your relationship with hockey, if any?
Okay, so I'm a rising junior in mechanical engineering and biomedical engineering here at CMU, and I don't have much of a direct connection with hockey, but I'm a huge sports fan. I love watching professional football, and with that, I'm also watching the injuries and everything. So that's definitely related to what we're doing here. And I'm on the track and field team also here at CMU. My seasons have been cut short a few times due to injuries. So anything with reducing injury in sports, I'm definitely interested in. So that really made me want to sign up for this and look into new innovation to help other sports with injuries as well.
That's great, Samantha. And it's difficult not to find sports enthusiasts in Pittsburgh. That's kind of my experience.
Yeah.
Hamza, I have not played myself field hockey in India, but I know the national sport of India is field hockey.
That's
so
right.
I wonder, does that have anything connection with your story?
Well, to be honest, not a lot, but I am a huge sports fan, and I myself, before coming here, I used to train for powerlifting myself, so I know what it is to be injured and not be able to participate, and then what it feels like to come back, and how long it takes to come back to full strength after an injury. So definitely related to I can relate to like the problems that are faced, especially in ice hockey. And ever since I saw the first game, I have to tell you, I am a sort of a Penguins fan now.
Yeah.
We did go to the game, so yeah, super excited to be working on this today. Yeah, like this week.
Cool. So let me just see. Yes, we have the audience is alive and we are getting in comments already. And please, audience, use this opportunity to ask anything about ice hockey innovation, which we will be going next. So, and you could tell me a little bit about the week, as it has been, I think, a really fast pace. I wonder, have you slept at all from Monday until Thursday? But can you, without revealing your secrets, because the big day isn't tomorrow, but can you tell me a little about what aspects of the player helmet have you been kind of looking on, and what has it been about the helmet that has intrigued you during Monday, Tuesday, and Wednesday? Now it's already Thursday. Samantha, maybe you first.
For us, we really wanted to focus on keeping the helmet as similar as possible in shape and feel, so that our idea could be easily adapted to with the current players that don't really want a lot of change. So that was a huge inspiration for us, just trying to make it a lot safer with the different forces that can be applied to these players' heads, but not change it that much, just so that our ideas are picked up. That was definitely a huge inspiration for us. And yeah, we sort of went forward with just trying to add safety through the different layers of the helmet without adding a lot of bulk.
Right, Hamza.
Yeah, just to add to what she was saying, I think there's like a whole range of different ideas in this space right now. Like every table is doing something else with the helmet, but like the goal is the same. So everybody's focusing on different parts of the face or the helmet. So essentially, it's about like how do you protect the players at the same time, make them more comfortable, make that addition to the helmet. How do you add something to the helmet in a way that does not impact gameplay at all?
Yeah.
While making you feel better when you're playing. So it's like a challenge, and that requires like a whole range of mix and matches, permutations, and combinations. So we're going through that cycle. So yeah, it's exciting. It's amazing.
Yeah.
To be able to look at all these different aspects of the game and the helmet.
And I think you, I mean, even though you are specifically looking at hockey helmets and the game of hockey where you have this insane speeds and of course pucks that fly with insane speed, but I think you also look at other sports. So you're having a pretty holistic view at protecting the head, which is kind of nice because I think our audience, people play sports where the helmet is needed. I mean, I have fallen on ice many times, too many to remember, but I've always fallen on a bike. And, in both cases, you need head protection. So maybe you can talk a little bit about how much did you kind of look at other sports when you were kind of looking at the hockey helmets?
For us, we're even referring to other studies that have been done with football helmets to just back our research and just show us what's the best way to do what we're doing based on other studies that have been done. For football, which is probably the most similar sport in terms of having a helmet that's going to protect them multiple times a game against some pretty severe head impacts. So we were definitely looking a lot with the similarities between football helmets and how those have changed through the years and the innovations that have gone into those. And then looking into the space of hockey helmets and seeing how they can improve and what can be moved from football also to hockey.
Absolutely. And we're also looking at, so our team was also looking at bike helmets and other motorcycling helmets to see and understand what other components can be used to, sort of increase the safety, sort of to bring in that extra layer of comfort maybe. So we're looking at, because with those kind of helmets, you sort of wear them throughout the day. There's like a lot of sweat, especially with cycling. There's like a lot of sweat. So how do you, innovate with those materials at the same time? Then integrated with what you're trying to do here and achieve your goals. So there's like a holistic view in terms of like what materials are being used and what kind of helmets give you inspiration.
And you're getting such an intense week of helmet design. Any employers out there, if you want to make the world's best helmet, you want to hire Hamza or Samantha because they know everything about helmets by Friday. But this is now the first Make-a-Thon, where you're kind of limited by the physical contact, and you have been not able to kind of get that physical. The materials, I guess, are still physical. I hope for the most part, but the coaching has been virtual. So, from your perspective, looking at the way you have done this and the way you have kind of had this exchange, are there only downsides, or are there some even upsides to this situation?
I definitely think there are both downsides and upsides. One nice thing is just being able to switch between different coaches so quickly because you're just in a meeting, so there's no physical moving around or anything. So it could definitely save in time efficiency, but it's definitely difficult as well to try to communicate through a computer. But fortunately, we've been able to communicate the ideas pretty well.
We've had some practice over the last semesters, switching between rooms, getting used to the virtual screen, being able to focus and answer questions. And we're like really handsy, so we're sort of like, we know when to go closer to the laptop, when to like come back out. So those kind of things. So it's we have some practice.
I got to say, I mean, you seem fairly comfortable. You naturally move towards the camera when you show something, and that's appears very fluid. But I definitely hope that the further Make-a-Thons can be held in person. And we have a first question coming in from an anonymous LinkedIn user. So let's take a look at that. The question is as follows. Have you ever thought about implementing airbag technology on the walls around the rink that activate via sensors? Wow.
That's definitely an interesting proposition. We are working around helmets right now, and it's not far-fetched to think about airbag technology, to be honest. But not talking too much about what we're doing here, but that technology definitely has been thought about in the previous years as well. So it's not far from it's not far-fetched, honestly. And then activation via sensors is something definitely that can be looked at. But you also have to look at other aspects of implementation in terms of how do you retract the airbags back in, what kind of sensors do you use, and then you also have to think about the environmental conditions on the rink, with the speed of players coming in and going out. So who gets detected, who doesn't get detected, how do you detect them? So there's a bunch of things that you have to think about.
We've even looked at automobile crashes in our research, and just through looking at different ideas, we looked at cars and how they crash and crumple and airbags and everything as inspiration for our design as well. So.
And I think this is a good point. And of course, we had the first Make-a-Thon was about the dashboards around. Dear anonymous LinkedIn user, feel free to look at Make-a-Thon 1 to see the different ideas around what were reflected during the dashboards. As someone who played in Finland ice hockey a lot, I can tell you the challenge is, of course, that as you play hockey, you touch the boards fairly often, and it's being used actually all the time during the game. So the question, I guess, is that once the airbag activates, then it doesn't go back anymore. So as far, I'm not a mechanical engineer, but that's I think also a challenge that we have with airbags, because they only go one way and they don't go back, and that's kind of the challenge with that technology. But I can also see that you guys are looking at everything and everything that exists, and maybe one comment on that. How does the Tech Spark facilitate your thinking and your ideation, as you have been have all these facilities? Do you kind of have the feeling that you can do anything that comes to your mind, or are there some constraints from your point of view?
Yeah, it's great to just look around and see different machines will give you different ideas of what to do, and it's pretty limitless. There's someone everywhere to help you with all of the different machines.
You have pretty much all the tools. You think about cutting something, or you think about making something, or fabricating something, to the point if you think about hey, I want to make it look cool, can I spray paint it? And there's a painting room as well. So it's it's about what do you want and how do you want to sort of like, it's about like what process you want to follow, and then you have everything available to you.
Yeah.
It's pretty amazing to be able to work in this space. I think that's what makes it possible within this league, actually, to have everything in place.
Yeah, this is definitely a great space
Yeah.
to work, a lot of room and everything. Yeah.
No wonder the Ice Hockey Make-a-Thon is there now for the fourth time, because I mean the magic certainly seems to be happening at that place. So Samantha and Hamza, I mean, if you have had, I mean, I hope you will sleep before the grand finale tomorrow. We wish we'll be, by the way, also streaming live afterwards. So make sure that you tune in for that tomorrow and see Hamza and Samantha, you know, after the big finale. But what are you doing next? What's happening between now and Friday?
Well, for us, we have to iron out our presentation, make it the poster board nicer, and just make sure everything's flowing smoothly in terms of presentation. But our prototype is basically done, so just doing a little bit more research and then, putting the presentation together for us. Yeah.
For us, it's like we have all these different components and different parts of the prototype in place. So it's putting them together and sort of cohesively presenting that to the judges. So working on the poster and things like that, and adding those final touches so that we're crossing the line on time. Yeah.
Cool. Well, Samantha and Hamza, thank you so much for taking time out of, I know, incredibly busy schedule and an incredibly busy week. It's fantastic to see you. Thank you for chatting with our online audience, and good luck for tomorrow.
Thanks for having us.
Thank you. Thank you for having us.
Thank you for participating at the fourth day of our daily live streams from the Tech Spark, and tomorrow will be the grand finale of the Ice Hockey Make-a-Thon. So make sure you tune in at the same time, at the same channel, and we'll have the opportunity to chat with the amazing colleagues from Carnegie Mellon, Sandra De Vincent Wolf and Diana Hyder, the masterminds that run the magical wheel of rapid innovation. So until tomorrow, stay safe, stay healthy, and bye-bye. Okay, I'm ending stream here.